in computer vision with Python. I would like to thank Utkarsh for inviting me to this talk. So, a bit about myself. So, I'm an incoming data scientist and software engineer at IoT Technologies. I have been an open source contributor to few organizations. I'm a data science enthusiast, and I think that's all about me. If you want to know more about me, just check my LinkedIn profile or Twitter profile. So, is it? Am I audible? Can anyone give me a feedback, because it's a bit hard talking in this virtual format? Is it? Is it audible? Hello.
Yeah, you're audible. You're audible.
Okay. Okay. Thank you. So, so what is the field of computer vision all about? So when we think about vision, okay, if you think about just this image, so when you are looking at this image, you see there is a human, there is a young girl with a dog, and that young girl looks happy while the dog may or may not be happy. So how our what we perceive as computer vision is usually something very simultaneous to our human eye. So right now, in the state of deep learning, since we are in a deep learning.ai meetup, we are interested in deep learning. Right? So the state of deep learning to beat computer vision benchmarks is already established. So for classification tasks, some of the deep learning algorithms can do even better than most of what the other computer vision algorithms can do. So most of the and even better than a human too in some tasks. So what all are these some tasks is like, it's very general. So for if we are given a image of cats versus dogs, we as humans can identify to a limit. So if we give a computer with lot of images, with lot of data with it, so you are automatically able to identify what it is based on computer vision. But when there is minimal data, our humans have this ability to learn and forget, which is something very interesting and important as well. So that's something which computer vision has not so far achieved yet. So let's talk why Python, and I told you the why this talk is about introduction to computer vision with Python. So if you think about the languages like yeah, so if you think about the various languages, Python is a just one among the languages. Like there are multiple languages like C++, Java, and all this. But in any machine learning application or data science application, Python is usually preferred. So I am assuming most of the audience here at least know the basics of Python. So that's, if you know the basics of Python only, you may be able to follow along some of the code examples which I will show today, and the concepts which I will show. So if you want to learn Python, I have some of the resources like, so uh, Python Automate the Boring Stuff with Python is an excellent book. So yeah, this book is an excellent book. And even if you take the Andrew Ng course of deeplearning.ai, they teach the basics of Python, the important libraries which you need to learn. So and in this course, in this textbook, Automate the Boring Stuff, you have a lot of things for the basics of Python is included as well, and it covers a lot of applications too. Another book which I recommend to intermediate users, which I recently read, was Python Tricks by Dan Bader. So this is where, like in Python, if you are learning Python, it's definitely important you learn various techniques. You learn the various OOPS concepts, functional programming concepts, etc. So it's, yeah, always useful, very useful when we are building a model. So that's where you need to learn Python. So these are some of the resources which I would like to learn. And if you are getting started with Python, maybe I would recommend the course Python for Everybody from Coursera. It's a very excellent course. So so, is there any other languages for deep learning or computer vision for when you want to program? So, in my opinion, this is a yes and no question. So, yes, there may be other languages. There are a lot of good languages like Java. Java can be used for computer vision as well, and there are some libraries as well. Some of the emerging languages like Shift, Julia, etc., can do computer vision. But the problem with all these languages is all these languages are well designed and all the stuff, but I think none of the libraries or languages have the packages like in Python to do computer vision. And also one another important aspect, why Python language is being used a lot is because most of the advances in computer vision is done by the researchers, the so-called researchers. So for researchers who are doing PhD work and all, Python is a very easy language to but do their work on, and it's very English like readable language. So that's why Python is being preferred by almost any other people, almost all the people in the computer vision and data science community. So I will just get started to computer vision with a live example. So we are going to build face mask classifier. So all you really so you may be thinking, okay, I didn't teach any basics, I didn't teach anything. So this kind of approach is called top down learning approach. So when you're working on any problem or something, so let's take the example of playing cricket. So when you're going to play cricket, what do you do? Do you learn like how to bowl a dusra or how to spin or etc.? You just play. That's basically top down learning approach. So in what top down learning approach process is, get straight into your application, get straight into what you are building on, and after that you can do the meaningful stuff you are interested in and work on things you are truly passionate about. So as you all know, right now it's a time of COVID-19, and initially if you think like face masks were not a very acceptable form. So but over the time, I think a lot of people have started using face mask, and a lot of the government has also advocated that. The reason I guess is because there is a lot of studies by the people, like why face masks are effective. Like I think why face masks, why I think Jeremy Howard from let's see. Yeah, so Jeremy Howard's I'm not able to, one second, let me find the exact article. First thing yeah, so it's one of the articles which really turned popular. So yeah, mask FAQ for skeptics. I think Jeremy Howard was a guy who told, okay, when the World Health Organization was saying, okay, it's not necessary to wear mask, and it's only needed for the people in the healthcare. Like it came with a lot of scientific evidences and told why it's important to wear mask. So that's how the culture of wearing masks became very popular, and and why mask, and also that's when do it yourself mask became popular. DIY mask become popular because a lot of people started wearing masks, and it was in like March was when the COVID started, and colleges and all stopped, and by April, I guess almost all the countries mandated that okay, it's necessary to wear masks, because countries which were wearing masks and taking safety measures were doing a better job tackling COVID-19 rather than other countries. So, so it's very important. So what I'm going to do is to build an application to classify whether a person is building face mask or not. So Linus Torvalds is the inspiration. Talk is cheap and show me the code. So I'll try to show all the code. So for this, I have used a library called Fast AI. So in Fast AI, it just takes like 3 lines of codes to do the 5 lines of code. To be honest, this is 1 line. So item transform. So it's basically to resize the image into a particular size, that is 256, and then you do some augmentation techniques like flipping the image, rotating the image to something, adjusting the lighting conditions, etc. You load the data with data is equal to image data loaders dot from underscore folder from path, and you are able to create a CNN learner. So learn.cnn learner, you data ResNet 15. So ResNet 15 is a very this is the data which is being loaded, and we are able to classify as well. So I'll just show how it's being built. So this is very interesting, like why you should wear masks, etc. So yeah, I'll show you the code for with and without Fast AI mask. So if you look at the data set, so when you are taking any computer vision problems or something like that, so the first thing, one thing where I think machine learning totally gets different from other forms of software engineering, etc., is where in machine learning we need to deal with 3 aspects. That is, in the first we need to deal with okay things like sorry. So in first we need to deal with the code which is being used for modeling, etc., training and all the stuff. Then another important aspect which you need to look is the data. So without data, machine learning is nothing. And as you all say, as you all know, like it's now a very new paradigm to see that data is the new oil. So this is a data set which I have taken from Kaggle. So in Kaggle, someone had created a data set with 12,000 images of a person wearing face mask. So face mask and no face mask. So if you look at the data set, it has 3 folders. That is train, validation, and test. Okay. And if you look at the train folder, there are 2 labels, that is with mask and without mask. So in case of with mask, you can see there is a lot of images where people are seen wearing mask, and all the images are resized because it's obvious that we won't be able to get such a small data. So, and similarly in test also, there are in test data set with mask there is 483 files, and without mask there is 509 files, and in validation also there is 400 files with mask. And 1 second, 400 files with mask and 400 files without mask. So if someone can unmute, can you tell me like what are we trying to classify in this problem? You can comment also in the comment box if you want. So I think can someone reply? Okay, I saw some center. Yeah, whether a phase was okay. I will just say like so I showed you how the data is being. So in the data, if there is a training folder, this is a face mask data set with 3 folders: train, test, and validation. There is it's a very almost all the problems are being divided into 3 folders, but I will explain that in detail. That's not important right now. So what it is important is, what are you classifying in this model? Yeah, well, someone said whether a face has mask or not. Yeah, that's true. So that's what we are classifying. So in our data set, we have 500 images of with having people having masks, and 500 images of people not having masks. And you are trying to build a image classification algorithm such that you are saying that okay, if someone is having you're building your computer vision model such that okay, based on the image you are able to understand okay if the person is wearing mask or not. So if it can be very useful like for surveillance and all. So if as you all know, in like in Kerala we have like um 200 rupees fine, I guess, right? 200 rupees fine if you are not wearing a mask. So if you are not wearing a mask, you will be fined 200. So if the police can, there are a lot of cameras already in our streets. So if the police decides to embed the software and like some start finding people, then we are able to make a lot. Then the police will be able to like, make a lot of money, and it's very easy as well. So um, so I guess you got what I see. So I'll show you the code on how we can train this. So I just showed the simple code, like what the model is about. It's just 5 lines of code. That is, take the model, apply some transformation. So the transformation is resize, like all the images may not be of the same size. So we fix all the images into the size of 256. Then you do some transformation. So the transformations can be like resizing, randomly resizing, cropping images into 224, then like doing some augmentations like rotating the images a bit, flipping images, etc. It doesn't matter. Then you load the data with fast AI method, image data loaders dot from underscore folder path, and call the batch transformation and item transformation. Then you call the CNN learner method. Learn is equal to CNN dot learner data ResNet 15 metrics is equal to accuracy, and you train it for 3 epochs. It's not actually 3 epochs. It's like there is a method in fast AI which um, you know, monitors till how much optimally monitors. It's like a partially okay, it doesn't matter right now. Like it for on training, like for 3 times you are able to get the best accuracy. So let's look at the code for doing this. So if you are looking at the program, we are importing the modules like from first AI2 dot basics import star. So this may not be very comfortable for you, because if you are coming from a software engineering background or something like almost you usually import uh, with the specific information, but we are using a wildcard to import everything, and it's not recommended for doing in when you are building models for production or deploying. So you should never do this when you are doing production, but this is a very experimental project. Then I'm going to take the I'm going to set the path as the file folder path of the data set. So in Kaggle is always dot slash Kaggle slash input slash, and this is the name of the data set. And I have defined there are 3 folders. So for that I just created train underscore directory, validation underscore directory, and test underscore directory. And for modeling, we loaded our model. I explained what all this code is about. So what it does is like, okay, so we create a image, we load the data such that we set the path as, we set the training path as path, we set the folder of the, we set the path as the file location, and we set train folder with its name. So you know, the training directory is in face mask dataset, the file which is a folder which is named as train, and in valid, the it's called validation. The please be sure that when you are doing like ensure that all the caps and all have been properly modified. And if you are looking at the class, like as someone already said in the chat, we are going to predict whether a given image is with mask or without mask. Then we randomly look at our data using data.show underscore batch command, and we create a learner. So a learner is equal to cnn.learner data. So we launch the data set. We create a model architecture. Just think it as a model architecture. So that's like, okay, we say that, okay, so we are not training the model from scratch, right? We are building already, we are already taking some of the domain knowledge, and that domain knowledge is reflected by the model called ResNet 50, and we create a metric called accuracy, and we train the model for 3 epochs. Since the model early stopped, we got a perfect accuracy of 1. So almost all the images are correct on classification. And if you are looking, okay, what all are some of the images which are getting wrong? So you see, like our model predicted this is with mask, but obviously this is like, you can't say this from a human vision, right? Because the pixels are a bit distorted. See some of the black and white pixels which is predicted as with having mask, while what we should have done should have been to clean our data set first, but that doesn't matter right now. And we are a confusion matrix is a matrix which shows, okay, how many images, how many models which I have labeled are correct. So almost all the actual models have been correctly predicted as having mask and without having mask. So I'm just checking one of my images, and when I predict, I'm getting the label that it's my image is having a mask. So if you have any questions till now, you can ask in the chat. I'll just, and you can just, if you are interested, you can look at the kaggle.com Kurian Benoy / with my or without face mask fast AI2. So maybe you can look at the code for 5 minutes, and we can just, if you have any question, you can ask me also during this time. So this is the URL if you want to look. So someone asked in the chat, like, what if we find the reason for wrong prediction? As in, like, okay, too much beard is classified as mask or something. So if you see that your model is being doing a wrong prediction or something, you can do a bunch of techniques, like maybe choose a bigger machine learning model. Then like sometimes the problem is with the data itself. Like sometimes your sometimes in the training data someone have label the person having too much beard as mass. So in that case, you need to clean your data first, and based on that, do your analysis. So I guess people don't have a lot of questions. So if that's the case, then let's move ahead. So that's the code which I talked about. So if you have any questions, feel free to talk as well. Any questions? Yeah, so 1 second. I will share the Kaggle link. Okay, I'll share the Kaggle link in the chat also. So I have shared the Kaggle link. Yeah, one other question. Okay. So I hope there are no more questions. So let's move ahead. So what is computer vision? So we humans, as I said, we perceive our eyes as something very gifted, and like it's a lot of, we think it's something which we got very natural and things like that. But actually, our eyes have been shaped by a lot of learning and a lot of experiences. So it's like a kid which is being growing. So this is something which is always told as an example of supervised learning, unsupervised learning, and reinforcement learning. So I really want to ask this question, like, should I explain all these concepts to you? Because I guess if you know that concept, like, can someone say what is supervised learning to me? At least mention it in the chat. We have some more time if you want, so we can talk about that as well. What is supervised learning? What is unsupervised learning? Okay, I think I'll just. I think I hope you all know what it is. Like, okay, someone had said that. Okay, supervised probably when you know exactly what the supervised involves human assistance, outputs are on. Okay, so yeah, what you said is right, because you know what exactly the outputs are. So like, if you are given a input, we give it a label, and the output is already being known. So the label, the training with labels, yeah, the exact answer which I wanted is, yeah, supervised is training with labels, and unsupervised is training without labels. And there is semi-supervised learning as well. So in semi-supervised learning, we have label data. We have very few examples of training data with labels. So in that case, it's being used in machine, like in medical data, and also in that case there are techniques which are very good as well. So as I told, humans, we, it's a art, and usually I echo with this thing, because what we think perceive as computer vision is not just merely something which we see in our see with our eyes. It's what we, it actually starts from the brain. It's told by Dr. Fifili, which who is a very famous professor in Stanford and takes the classes in CS231 courses. So this is always something which Andrew Trust says. So when you are like thinking about a self-driving car or something like that, so for humans to do a like to get a driving license, what you need to do, we just need to like pass the learner's test, and after that you need to drive a car through H, I guess, and ride it for like a few miles, etc. That can be done with computer vision easily. But the problem is, when computer vision is being done, it's always thought like, okay, we highlighted the mistakes a lot. So if a autonomous car was just supposed to do the driving test, it may have already done that way before, like maybe in 1990s itself. But the truth is, that's not we want. Like, we need to do the lane detection, um, pedestrians shouldn't be hit, and so that it involves complex technologies like lidar mapping, etc., radar mapping and stuff like that. So obvious.
Yes, tell me.
So when we are thinking about computer vision, we think like, okay, our eye, when we think about computer vision, okay, it's always thought as something which can beat the humans in something. And so that's where that's where the aspect of brain also comes in. So let's look at some of the common computer vision tasks which is being used for. So some of the common computer vision tasks which are being used for are image classification. So in image classification, given this is a these are a set of flowers, and based on computer vision, we need to classify whether the given images are belonging to a particular class of flowers. So there is an ongoing Kaggle competition right now. So where you need to detect flowers, like there are 101 varieties of flowers, and based on that, using our image classification model, you need to predict, okay, which flower it is, and you are able to easily get like an accuracy of 95% or 96% very very easily with those problems, even though it's very hard when you think as a human to do, because I this is something which I always experience. So this was one of the projects. I'll talk a bit more after this time. Like, I did a small project where I had to classify the various kinds of Indian plants, but like, I don't know more than like 10 varieties of trees in my locality. So it's a difficult task for even for a human to remember and classify which image it is. So another important task is object detection. So object detection is used like, so this is based on an image, okay, what each entities belong to. So there may be a set of objects, there may be people, there may be cars. So for object detection, we usually use bounding boxes. The red colored and yellow colored are used called bounding boxes, and based on these bounding boxes, we are able to say like how much people, how much objects are there in a particular image at a particular point of time. Another important application is segmentation, where we classify the images into various levels. So it can be considered something as coloring, where like we humans may be labeled as some specific color, while the roads and the cars may be labeled as some other specific colors, while the buildings may be labeled as other colors. So unlike object detection, where you need to you need to label all the objects, it's way more easier in segmentation. Another important sorry another interesting task is activity detection. So I think regarding segmentation, segmentation is used in medical imaging a lot, like for detecting chest I forgot the name, like uh, for chest x-rays and all the stuff. It's being used in a lot of medical image applications. Segmentation task is being used a lot. So another important activity is activity detection. So some things like dancing, diving, etc. So based on that, our computer vision model will be able to predict whether what activity you are doing currently. So it's a very important and necessary application of computer vision. Another application is post detection, like what all poses that the human is being done. So there was recently a paper like so that which like told that like in the near future with a very advanced model, our steps of dancing can be replicated by that model, and we are able to basically if someone like okay, basically the model what it did was like, okay, if someone if I just dance, it can be super related to a picture of like AR, maybe Amir Khan or like Shah Rukh Khan dancing. So that's also a very interesting application which is being developed. Another unique aspect is um, you know, identifying the person. So like if there is like important persons like Barack Obama or something in an image, it's important to identify who they are, and it's usually not used very much, but it's also possible with computer vision. So do you know who this Adrian is? I think majority of people don't know that. So Adrian is from PyImage Search. So it's a very reputed blog, and you can usually follow along their courses and do anything as they have a bunch of amazing tutorials and computer vision, OpenCV, etc. So do check PyImageSearch.com. So let's look at some of the applications of um, what you can do with computer vision.
Air pollution.
Was that audible? Yes, okay.
Pollution is one of the major problems which Delhi people are facing.
PM 2.5 pollutants hit new season highs today, up to 30 times safe levels.
If you want to know the air quality just outside your house, you need a portable air quality meter, which is expensive and difficult to carry everywhere. We are engineering students and we strive to do something for social good, so we came up with the idea, why not make people aware of the air quality around them?
Air Cognizer is a mobile application which allows you to click the photo of the sky region, and it helps you to know the air quality around yourself. For this project, our mentors introduced us to TensorFlow. It helps us to do on-device computing, which is really quick, and also make the app portable to use.
What they needed to do was learn from images the level of pollution. And for this, we needed a platform which was easy to tailor and current.
The very first task was to capture an image and extract certain features which could be utilized for figuring out what is the AQI level of the atmosphere.
We clicked images in various locations of Delhi and we created a data set of almost 5,000 images. We used this data set to train our model.
Air Cognizer has 3 models. First is an image classifier, which classifies if the image has sky or not.
The second model is a meteorological parameter-based model.
Third model is customized for every user. It's an image-based model and takes image parameters to predict air quality index.
TensorFlow Lite helped us with compressing the size and deploying all the 3 machine learning models on device.
With binary size of 10 to 20 KB, it hardly occupies any of the space on the device. Also, it doesn't consume much of a battery life and it's really quick.
We got an email from that first user that I'm using your app and it's working pretty well. So it gave us the confidence that yeah, we are on the right track.
Until and unless you don't know the severity of the problem, you can't act to it. If we have the knowledge as engineers and the technology with us, we can provide a solution which could help citizens to know their quality around themselves.
So as you can see, using their model, they were able to predict the air quality. So if you've seen that, like one of their models was image classification model, where it was to predict the skyline. Okay, like whether there is enough, given an image, whether there is enough, enough amount of the sky being available to monitor the monitor the estimate the air quality. So for that you can actually use the model which we just trained now, like instead of with and without mask, you can create a data set with images having sky being appeared in one of the models or one of the data sets, and in another label there is not enough skyline, like the sky is not clearly visible. So in that case you can also create a air quality model like that. I think it's stuck. One second. One second. Yeah, I think now it's working. So another important aspect is, okay, is there any questions? Okay, that's fine. So another important aspect is used in biotech AI. So in biotech AI is used for is this is a slide of image for prostate. So prostate is like a type of cancer, it's a particular gland which is there, and based on that, it's a common cause for cancer. So how you identify the cancer is usually by checking for the patterns in the image and identifying, okay, what is the Gleason pattern which is being present there, and assigning each Gleason score as, there are like 5 scores of Gleason, that is like 0 plus 0 means basically there is no cancer or something like that. But if there is any pattern which is having like 3 plus 4 or something like that, you grade the cancer based on the intensity. So there are like, okay, if it's 3 plus 3, the intensity is 1, and if it's 0 plus 0 or something, it's 0. So it's like a grading platform which is being used for like grading the possibility of cancer. So it's used in a lot of biotech applications as well. Another application which I used was plant classifier. So similar to the flower classifier, I really didn't have that image. Like 2 years before, I created a it's difficult. Why I created this project was because, like, for me, I am not able to identify the various plants in my trees in my home. To be honest, it was a tree classifier. So given a chakka or manga or chakka flower, or there are like some other plants as well, like, which is difficult to identify. So given that machine learning model, I was able to identify, classify which plant it belonged to. So that was one of the applications which I used before. Another use case is, one second. Hello. Okay, so another thing which can be used is, it can be used in artwork a lot. So this is called neural string transfer. Given an image, it can be transformed into like human painted stuff like that. So it's also possible with AI a lot. So I can show one application which, it's my GitHub profile itself. So given this image, this is actually like a real world image, but it's actually cartoonized. So it's called white box cartoonizing. And there was a recent paper in CVPR about how to use this model. So that's also a very novel application where you can use white box, cartoonize any given image you want to do. So if anyone is interested in checking that project, you can check my project at the repository cartoonizer. So all you just need to do is like install the requirements. It's basically a Flash web app. So if anyone is familiar with web app technology, you can just run it. Like, just install the requirements, run the main.py command, and given any image, you can classify it like real world cartoon like images, and it's being used in a lot of real world projects, and like, it's a very fantastic thing. So if you are interested, do check it out. So this is also a lightning talk which I was really inspired by. So this is something. This talk is not merely about the application which he talks about, but it's also about it's used to talk about why you should learn deep learning. So this talk is being given by Bhuwana. She is currently a deep learning engineer at Sama Technologies. So she started learning deep learning at the age of like 40, I guess. And it's very interesting how she created real world projects, and she talks about a few of her projects. So one of her projects is best classifier. So best classifier is like, so given like the bests may be different in various careless, like KSRTC difference and a Tamil Nadu RTC different best is different. So she collected the data set of various buses which is running in the state highways and etc. And based on that, she created a image classifier which is similar to the model which I showed, like the face classifier. And based on that, she was even able to land an excellent job. So you can check this video as well. Just let me know if the video is audible or not. Oh no, sorry.
To all present here. My topic is novice to ML researcher. So who am I? I'm the research intern at Sama. So this is my background, and this is how I started my career with banking. And then I was with Deloitte doing financial auditing. Then I was the founder of a STEM edtech startup for almost 7 years. And then I became a research intern. So you're going to hear about my journey. So yeah, what was the turning point? As I mentioned in the previous slide, I'm the mentor for Technovation. I'm an advocate of girls in technology and women in technology. Why? We know. Yeah, you can just take a look around and see how many women are among us. It's not that women are not smart or intelligent or not in STEM, but there's somewhere, we need to do a lot of work to bring in to STEM. So I was mentoring these two girls, Tanya and Mridula, and we were one of the finalists out of 10,000 participants in 125 countries, and I had the opportunity to go to Google. Yeah, I was there in the Google campus for 5 days, and then it struck me really hard. Okay, as a promoter of women in technology, girls in technology, and I'm not in technology. That's kind of, very absurd. So when I came back, all I could see was all the AI in headlines. Yeah, so I said, I'm going to become a technologist myself. So it's really hard to do something and keep doing at it, and it's also hard to stop doing something, right? So yeah, this is how it's going to look like. Having known my background, it's not so easy, but I was prepared to do it. Yeah, how many of you saw all the ML talks and AI talks in the last 2 days, like yesterday and today, and thought, yeah, maybe I should get into ML? Can you show up your hands? How many of you think yeah, should I get into ML? Yeah, I'm going to say anyone can do ML and DL. Yeah, you can just search ML AI in Google, and these are some of the things that's going to come up. But yeah, FastAI was to my rescue, and last year was my first Pycon. I never knew something like that existed before. So last year was my first Pycon, and this year I'm here talking to you guys and girls. So FastAI, I don't know how many of you have heard about FastAI. Show of your hands. That's good. And I keep telling Jeremy as my mentor. So why FastAI? Yeah, it's a top-down approach versus bottoms-up approach. So the basic thing I did was, did an ML course by Andrew Ng. And then I went on to start deep learning because I saw all scikit-learn libraries, do a fit, then predict, not challenging and not interesting enough. And as a woman at 40 trying to get into tech, right, how tough it is. And with a non-traditional background, doing every bit of, finance, entrepreneurship. So I thought I had to do something niche. So I started doing. So yeah, Swimming, you learn swimming, get into the water and swim. You want to play football, go to the ground. So this is what Fast AI preaches. And if you look at all the blog posts, right, so they'll teach about how to classify dogs versus pets and identify the movie review sentiments, right? So this is Fast AI. It has like 7 courses for the part 1 and then 7 courses for part 2. So you get to learn to build a movie review sentiment, a recommendation classifier, recommendation engine building, and then classification and all that stuff. Okay, so all these concepts are demystified. And then you have discussion forums, you have a share your work here. So what I wanted to, I want to just give like few lines about what I built. I didn't want to build a cats versus dogs. Yeah, this is some bus in Bangalore, Karnataka. Yeah, this is another bus. So my parents had the trouble of finding the bus names when they travel outside of Tamil Nadu. So I wanted to build a bus name board classifier. And as with all ML models, I had tough time, finding data. So I started taking a small problem in my particular area in KK Nagar. So I started hunting down for bus boards, right? So I just go and start clicking pictures. I created my data set. And then, I had, so this work is in my GitHub. You can just check it out. And this is how I went about pre-processing the data. And then I built a bus name board classifier in under like 3 months. And the next thing I wanted to do, I wanted to have a text classifier. So I wanted to build a sexist remarks classifier. So again, I went ahead and hunted data online. I have built a data set. Anybody wants to work on, you can reach out to me. It's not made public because again, there's a huge bias, right? What appears normal to me may not appear normal to others. So I have not made it public. And currently I work as an ML researcher with Sama, and I thank Malaikanan and Sama team for believing in me. And yeah, if I can do it at 40, everybody can. Thank you.
So as a talk said, like, okay, if anyone can start their deep learning, your journey, even at 40, you can also do that. So it was a best board classifier, not a best classifier as well. Even you can do a best classifier as well. So I'll just get into the basics of image classification and how you can do the various process. So as you know, given an image with a set of labels, which is already being predefined, our aim is to create a classification model so that, okay, as in this given example, okay, given an image, there will be a bunch of images with mask and without mask. So as our COVID-19 classifier, our aim is to create a machine learning model, and let's understand some of the concepts necessary for computer vision as well. So it's not always necessary to understand stuff, but if you want to go further in the career, it's always very important that you understand the basic concepts and how to the basic neural network architecture and its basics, etc. So some of the steps for building a machine learning model are, so most of the machine learning models can be attributed to basically 5 steps. So first we need to take a look at our data, like apply some techniques like look at our data, check if there is corrupted image, so I'll explain what it is there. And the next step is data processing, building a baselining model, training, evaluating our model, and it's always repeat. Like obviously our first machine learning model is obviously not good, so do and repeat your stuff and improve your machine learning model until you reach a certain criteria of baseline. So in first step we look at the images. And another important thing is to check for corrupted images or something like that. So as I said, in our image classifier which we built with or without face mask, there were some corrupted images, like this black and white images. This image should definitely not be in our data set, right? So remove some of the data sets. So it can be like you need to clean our data set. So that's one very important part of machine learning, modeling, etc. I'm talking all this assuming that you have a data set. Like at the end I will show you what you will do if you don't have a data set as well. So that's the case. So you need to clean your data set, check for the class balance. Like usually, so what I mean by class balance is like, okay, yeah, there are like in the case which I in the example I showed, having taking images at taking images of with or without mask. Imagine our data set was like, okay, like there were like 9,000 images, or with 9,000 images of people having no mask, while there were like 1,000 images of people only with mask. So our machine learning model automatically will only predict the images which have, which will predict with more probability the images without mask. So it's always important to sample your data set so that the various labels and the various labels are classes are just the same thing, like with or without mask. So you need to do that. So for this example, I'm going to take a data set where I am going to load the data set using Keras library. So in Keras library, I'm going to load MNIST dataset. So it's a bad assumption, like assuming what is MNIST dataset. So what MNIST dataset is okay, MNIST. Wait. So what MNIST dataset basically is like, it's a labeled image data with like data where of handwritten images of integers like 0, 1, 2, 3, etc. are being there. So each handwriting may be different. So our machine learning model is using our the given data and labeling that, whether okay, based on the writing, whether it is labeled what that integer is. So it can be used for a variety of it's a very common data set which is being used in deep learning models, because it's a very easy data set to classify, and it's black and white images as well. So that's about it. And we may want to check about its train label distribution, whether how many images of zeros, ones, and twos are etc. there. So as you can see, there is like 5,923 images with with images having the label 0, 6,742 images having the label 1. So it's not a perfectly class balanced data, but it's almost similar. Like it's not like 9,000 images versus 1,000 images. It's almost similar. So it's okay. It's a data set with okay class balance. So I'm not doing anything for pre-processing, etc. So another important step is data preparation. So one of the problems which most of the images does is like most of the images may have different height and width, different resolution. So it's always, so for our machine learning model to work, it's always very important to resize our images. So when you're resizing images, it's always a good practice to resize your image to 224 px, because it works perfectly fine. Then there are various pre-processing techniques like normalization. So normalization is like, usually our images maybe from 0 to 255 or something like that. So you need to normalize such that it is between the range 0 to 1. That's basically normalization. The next technique is applying data augmentation. So data augmentations consist of like rotating our image a bit, so that even if someone has a bit skewed image or something like that, our model should be able to predict it. So when you think rotate, since this image perfectly shows the example, you need to be careful about the data augmentation you are doing. Or one common data augmentation which we often see is like flipping. It's like flipping and like random rotate, etc. So if you flip 6, it will become 9. So you never need to apply that data augmentation technique, because it's bad for our model. And why we use data augmentation is basically to improve the accuracy of our model, so that it has more variance of data, more variety of data in it, so that our model is able to classify even better. Then we can like model our image classification. So when you think about image classification, it's usually a convolution neural networks, but there are other types of methods as well, like k-nearest method, which is an unsupervised learning method. So let's look how we can just model a symbol model. So if you are building a symbol model, so so I'm importing Keras model and all. I'm assuming it's already being imported. So inputs is equal to Keras dot input, and since the image, the hand classified, the eminence data set is of shape 28 into 28. So I am taking the model such that my input is 28 into 28, and then I apply a flatten. It's to flatten the input so that the entire 784 pixels is being there. Then like I apply a few dense layers. So it's like dense layers, what it basically means is like various layers in deep learning. So I know, like, I hope you all know what the various layers of deep learning is. Like deep learning, I think the first image when deep learning is being thrown is like, yeah. So this is basically, so the input, there will be like 128 nodes of dense layers, and from that there will be 28 nodes, there will be 28 input. So how this model will be working here is like, okay, so there will be 28 image nodes here, and we are flattening so that it's like 784 nodes. Okay, why is it not visible? Is it visible now? Okay, I guess it's visible. So so in this layer, as you see in this deep learning layer, so we flattened our model. So there is like 784 input nodes, and based on that we create another layer such that there is 128 nodes. Then we create another layer such that there is 128 nodes, and there is then we, in the final output layer, we create a activation function called the dense with the as much number of classes we have. So since we need to create an image classification model such that we need to label images from 0 to 10, 0 to 9, we have 10 classes. So, and you call the model, you run the model.summary, which will share the like it will describe how the model is being there. So when I will show you a code, you will be able to understand even better that stuff. So there are usually a set of common image classification architectures. Like what was the image classification architecture which we use in the face or face mask problem? Can anyone say that in the comment section? I guess since now is saying, I'm just going to say it was a ResNet 50. Check this. So here it was, learn is equal to CNN learner, and we pass the model as ResNet 50. So this is a method. This is how you pass a model in Fast AI, and it's almost similar. Like it's always very easy to. So what this is usually being called is as transfer learning. So there is already a pre-trained model which is being trained on a large set of images, which is usually ImageNet with us, which is having like 10 million images, and based on that 10 million images, your model is already tuned and having the weights of that model, and based on that we use the same architecture. Like we use various architectures like VGG, ResNet 18, DenseNet. Right now the best model is big transfer. But it's not yet so popular. It's a very new technique. Like I guess it came like during April or something, this year April. And efficient is one image classification algorithm which is now used like a lot, because it's being trained on humongous amounts of data, and it gives the best performance almost all the time, except like for like face mask problem you don't need to use an efficient net because it's a humongous model. So you need to be careful which image classification model you are using. So yeah, so always you never need to train a CNN from scratch. You always can use transfer learning. So if you want to load, like how you want to load a model, and like in using transfer learning, so consider the application like in TensorFlow.Keras application there are various models like exception. You can even load EfficientNet, B0, DenseNet, all the models can be available. So you can just check Keras model speech. Let's see. Yeah. It's also, so it's, yeah, model class. It's not model class. One second. Application. Yeah, so in Keras applications, this is where like almost all the models are being there. So exception is one model which is very small in size, but gives a bit less accuracy. So you can see which all models gives good accuracy and which doesn't give that much accuracy as well. So there are just much models which are available in Keras itself. Even in FastAI also there are various models like ResNet, SResNet, etc. So use your models as you want, and you will be familiar once you get started coding in the real world. And you then only you need to understand all these architectures, how it is working under the hood, etc. It's not necessary that you learn all these architectures, you learn the individual stuff like that, and then do that. You just apply the transfer learning, you just apply the architecture. That's all you need to do. And so yeah, you always need to set the freeze the model and then load the input. So this is like a image with 150 into 150 with 150 height and 3 channels. So width, height, and 3 channels. So 3 channels, I guess all of you may be knowing, is like the RGB image. So if you are looking at any real world images, so if you were looking at my image, so it's basically usually a set. What computer sees is not like what humans see. So what computer sees is like a set of numbers, and based on that set of numbers there will be usually 3 layers. So that 3 layers can be the red, green, and blue. That are the 3 color channels, and based on that that matrix number is being passed into our base model. We apply an average pooling, like so why that pooling is left I will show you when I explain convolution neural networks. This is just a more classifier which was used for like something similar to like our face and not face mask classifier, which just needed one denseness. But if you are supposed to classify something like the mnist digits with 0 to 9, so you need at the output layer you should have changed the dense as 10. Call the model, and the next step is usually compiling and fitting. So when you are so this is something, if you are coming from a machine learning background like sklearn, it's always compile and fit. But yeah, it's so when you are compiling, there is usually 3 aspects. That is loss, where we will set the loss as the loss. So loss is based on how our machine learning model need to convert. So there are various loss functions like cross entropy, categorical entropy, sparse categorical entropy, etc. So optimizer is something like how a machine learning model is needed to go the gradient descent algorithm and what optimization algorithm. So the commonly used optimization algorithms are like ADAM, then there is RMS prop, etc. Then metrics is how you are choosing to evaluate your model. So that's basically metric. So you usually pass model.compiler with optimizer with a suitable loss and a metric, and then you load your data set. Decide a number of epochs you need to train for, and also decide the steps per epoch. So how many in an epoch, how many epoch, how many batch, how many in an epoch it may be divided based on the various batch sizes. So based on that batch sizes we with training accuracy and validation accuracy. So here the training accuracy is being represented by a straight line, and validation accuracy is being represented with dots. You can represent it with a straight line itself as well. And usually most of the deep learning model, it does is like, okay, it's like an optimization algorithm. It goes down the hill like, okay, and our aim is to find the optimal converging point where our model converges and where we are able to get the best result for the given metric. So the given metric can be accuracy. There are other metrics as well, like for for object detection we use metrics like MAP score, so mean average precision. So that's being used. So based on that optimizer we converge like that. So yeah, I'm not talking about, and how you are going to evaluate your results is also very important. So when you're training your model, always set a dumb baseline. Like by dumb baseline, what I'm meaning is like when you are training your model, it's always important that you like train your model with the minimum weight and the minimum, don't use the biggest image classification algorithm. Just use the smallest image classification algorithm. Don't use image data augmentations initially itself. Just go with the standard way. Check what is your accuracy. Then like when you are bringing a machine learning model into the real world, it doesn't matter like, okay, you got 100% accuracy or etc. It always is based on the public scrutiny. So for example, consider the case of like building a spam classifier. So in Gmail etc, we have seen how the spam, how various labels are being labeled as spam or not spam. So our model should be like at the end of the day, even though our model got 100% accuracy, if it's labeling all the data as spam, it's obviously something bad is happening with us. So always think with your logical brain that, okay, whether this thing is justified or is it trustworthy to do this experiment. And yeah, as I said, you can use labels like confusion metric. So if it's like a hand digit recognition, you can use confusion metric. So the diagonals represent the number of labels which are being correctly classified, and the other represents where, okay, so consider the case of actually the label should have, the predicted label was 1, but actually the label was supposed to be 9. So this is what confusion metric actually says. And look at some of the images and check what is its predicted label and what is its true label. And I will show you with a small example how convolution neural networks is applied in the real world. I'm not diving deep into the convolution networks because that's a topic which Govichata is going to speak up next. So I would like to show one code, which is one notebook, and if you have any doubts, you can ask me. We can also stay connected, but first I will show that example. So this is a notebook to classify images. So we are not going to classify human digit, our English digits. We are going to classify Kannada numbers. So Kannada numbers are like this. I don't know Kannada, but this was a Kaggle challenge, and based on that, you can first import all the libraries and load the dataset. So in this dataset, it's not being treated as a images. So it's the data is being passed as a CSV file. So why is it being treated as a CSV file is because you know, the entire images is being split into like you know 785 columns. So you can see in the train and test there are 785 columns. So why there are 785 columns is because like for each if you look at the data, if you peek at the data, so pixel for each pixel image, all the images are actually pixels, right? So for in a given image, like in a 28 into 28 image, the for a digit number 0, okay, it is being seen, okay, what is this pixel number for this handwriting digit, which all pixels are being activated. Like, okay, in a black and white image, it is obviously, okay, the in a black background, which all colors are coming as white, is which all pixels are being treated as white, so that the number is 1. Like, 1 second. So consider the case of this number itself. So if this was an image, then okay, the thing like raw is treated, the black line is being treated as the pixels which are being activated, and that pixels are being marked as 1 in the data set. So this is like a unusual data set, but it's okay, we can do that. Like, so pixels, there are like pixels, so you can see the in the training data there is the label which we need to predict, as well as there is the pixels also, like, okay, which 784 pixels, like which I said 28 into 28, and which all labels which are being activated are marked with the I. And we check the distribution, like how the distribution is. So as you can see, it's a the class balance. There is a proper, it's a proper balanced data set with 6,000 images, 6,000 images for each labels. Then we like do some data preparation. So what we do is like, so we classify all the, so that the values of the integers are being divided by 255 to normalize, so that all the numbers are between 0 and 1. Then we reshape. So reshape is being done here because like the images, this is the entire pixel is of 7,000, right? Like, so 784 pixels. So we wanted to convert the data so that it's like like in the proper image format, like 6,000 into 28 into 28 with one channel. One channel is basically the black and white images which is being used for the MNIST data set. If it's a real world image, we use the 3-channel data. So as you can see, so see there are 6,000 images, and height is 28, width is 28, and there is one channel since it is black and white image. Then we just encode the target variable, split the train and test data set, and this is called data augmentation. So as I told, in Keras we use data augmentation with the image data generator method. So what image data generator method does is like, okay, it sets the input mean to 0. You can do the various augmentations like rotation, width shifting, flipping, etc. And based on that you can do that. And basically what CNN does is like, so given an image, there is a filter, and based on that filter we are able to get an output. So there is various aspects like padding all involved. I guess Gobi Chadai will go in deep into it. And another important layer which we discussed is pooling. So what pooling does is like, I will just explain that. So in a given image, so if there is a pooling image, there is a pooling layer in it. So the earlier image, like in the inception model, we saw an average pooling. So if it's an average pooling, what we do is like 1 plus 2 plus 3 plus 9 divided by 4. And if it's, we segment it into four segments, like based on the metrics which we are using, like the pooling layer which are being used. So since we are using a 4x4 matrix, we go through each image like this, and then we apply the pooling. And based on that, since the given image is a max pooling, we take the digits to the maximum number here. If it's an average pooling, we average all the numbers and pass it here. Then this is an example of a CNN layer which is being used. So I guess Gopichata will go deep into this. So I'm not explaining it all, but basically there is a con1 layer with a filter and a sample rate, and then there is pooling, then you flatten the input and you get the output. So that's basically, I'm not going into detail because the next talk is all about that. And you can create your model. So this is basically creating all the models with Con2D. Con2D is like a layer in Keras for creating the filters, etc. If you want to use a like VGG model, I guess there was VGG model as well. Okay, I guess he didn't do the VGG model here. So if you want to do a VGG model, all you need to do is like import from the Keras application, just model.add VGG with the image size and add max pooling layer as well. And that's all you need to do for doing image classification algorithm if you are using transfer learning algorithm. So that's what majority of people do, since he wanted to explain the basics here. So that's what he used. And he used a optimizer algorithm like Adam, which by setting the learning rate, etc., set the loss and the metrics which I used to do. Then like we can monitor our learning rate using various schedulers, etc. I'm not going to explain all that because it's a bit things which are in depth. So that's all, and you are able to see your training loss and validation loss. So that's all about the talk. And if you want to look more examples, you can check the Keras documentation. It's being documented even in FastAI also. You can do something similar here. So if you are interested in the FastAI version of this, I have created a notebook. Which is solving FastAI with MNIST with FastAI. It's a even similar code. If you want to look at it, you can look at it. So that's all. And if you have any questions, you can ask me. And if you are interested, thanks for attending the talk. If you are interested in connecting, you can DM me and Twitter anytime. My DMs are open, and you can also connect in other platforms. So if you have any questions, ask me right now. So I guess since there is no question, it should be something real world, and you should be having some impact with it. So most of the deep learning projects which people list in the resume are like the MNIST dataset or things like face mask. You know, this face mask thing which I showed you, it's very simple, right? Every beginner can do. I saw in the newspaper that since when someone made this project, he got facilitated by like MP or MLA or something like that. It's very simple, and it's not a real world project, to be honest, because at the end of the day, it's something very easy, and like, okay, it's, you can consider it as a real world project, but your project should have some meaning to the public as well. So at the end of the day, never put projects like Titanic dataset, MNIST dataset, other simple problems, or any other tutorial examples. Like what I have seen mostly is like people put tutorials, take code from the tutorials and write it. We also have read the tutorial, so it is very easy for us to understand, okay, you have copied directly from this tutorial, so it's very easy to detect this. So if you're planning to do any real world project, what you really need to do is like okay, decide on something which you really want to work on. Then like what Buona worked on, like that Planck best board classifier. She worked on that for like 3 months, and it was something. It was an app, and it was useful for people. So one example which I can also relate is like a plant classification project which I did. So as I said, like it's image classification and it's simple as well. But I guess there is no one who has made an Indian plant classifier, and even I easily outperform Google's computer vision API with my very simple model. So you can list that in resume, like, okay, if you are interested in building a project, build something which is impactful, which no one has done. Don't copy from tutorial. Don't list MNIST projects and MNIST dataset project, MNIST dataset code, and Titanic dataset code as your projects. Never do that. So that's all which I want to say. So I guess since there is no one right now here, maybe you are, as Utkarsh earlier said, like you can take a break for like 15 minutes, and after that, Gopi Chata will be joining in the next session. So that's all. And if you have any questions, feel free to DM me on Twitter, etc. So that's what I guess.